I was muted. Привет, привет. Не спидраню сейчас. Сейчас уже нет. Full-time Jai streamer now. Yeah, yeah, yeah. Not actually full-time, but I recently watched my charts, and apparently I streamed more than 100 hours in January. And according to some other stream charts, this is literally my most streamed year ever. Even during my peak Hollow Knight hours, I used to stream less, even though I had like 10 times more average viewers. I guess streaming programming is less tiring than streaming speedrunning, so you can like do like 4 or 5 hours of programming a day, but you definitely can't speedrun as much. Hey Jumpy, hello, hello, hello. Yeah. But yeah, hi everyone. I don't have my laptop with me, so this is gonna be a little bit sketchy. I mean, I can kind of see some glimpses of bitrate information on my desktop, but it's not really set up for me to constantly be observing if stream is alive or not. So I guess if stream dies, I might not notice it for a while. I can, I guess, go for my laptop, but yeah, it's whatever. Whatever. So what are we doing today, right? So Jai ships with a whole ass Vulkan module with Vulkan bindings for Linux and Windows, actually, right? And it even has an example here. But this example says that this only compiles on Windows, which is unacceptable. And yeah, today we're gonna be looking into that. We are going to be looking into it. I can increase my font slightly for the people. Right. Disgrace. So I guess it's gonna be 17, right? Yeah, this looks fine. Flashbang. Yeah, there you go. So, well, the interesting thing is that I know almost nothing about Vulkan. Yeah, 2025 won't be the year of Linux. Need to fix it ASAP. True. So I don't know much about Vulkan. A long time ago, like many years ago, I think I went through Vulkan tutorial, like vulkan-tutorial.com, and I like draw a triangle on the screen, and then I haven't touched a Vulkan ever since then. So it is time to just YOLO it back. So this example, it has a main that creates a window, then prints available Vulkan extensions, then it does init Vulkan, then it does init device, then it does init swap chain, init render, and then it does something draw frame. What is draw frame doing? Okay, it does some, okay, I guess it just clears the color to magenta or something. RG, it's either I or RB. RB. So yeah, it's magenta, right? I guess this is magenta, and some other color too. Yeah. Memory barriers. Yeah, so I guess it doesn't do anything fancy, just like clears the screen. And so what I have to do myself is, well, first of course we need to compile it. Wait, not build file, it's gonna be example.jai. Yeah, so assert false. And if we go there, we see that to do if OS equals Windows, then Win32 surface create info, otherwise assert false. So that's gonna be our starting fucking point for today. And yeah, this is gonna be probably more fun than yesterday, because yesterday I was trying to parse XMLs and oof. Maybe not the best investment. Hey, no, I didn't give up on the XMLs, but I probably want to do it on the stream, to be honest. Or maybe I will, but later. So yeah, today I wanted to try something else, and as usual, as with any topic that I have, you know, I have this thing when I don't really approach any topic in a straightforward way. You know how you're supposed to just getting started guide. You like read it top to bottom, and you like gotta do it one by one. No. We dive straight into it. We see assert false, and we try to make it into assert true. Yes, this is how you make Linux work. Yeah, I guess at the end you will do result equals success. I guess that's gonna be the end, and init surface. So apparently Vulkan has surfaces. Wait, what? Try it. Just do this. Oh, there's some other assert false. Yeah, non-Windows versions, right? Wait. Hey, look at this, we compiled. So is this the end of the stream? Not all paths return value. Whoa. And if I run example, oh, it even prints available extensions, holy shit. And then Windows Surface extension failed. I mean, that's fair enough, right? Because we didn't do anything. Okay, let's see how do you initialize Linux Surface. Let me do this. Vulkan X11 window Surface, and we are going to flashbang incoming. Oh, I almost made it with no flashbang though. Like this, right? Yeah. So how to get Vulkan context from X11 in C closed? This question needs to be more... Man, I hate Stack Overflow. If you already got your X11 window, you need to define vk use platform xlib khr and create Vulkan compatible surface from it using vk create surface khr. vk create xlib surface khr. Or if you want to use xcb, no, Jai ships with xlib, so that's what we're gonna use. I would be happy to do it with xcb, but yeah. Vulkan example only compiles on Linux because, you know, it's just what people submitted. Those extension printout, yeah, might be useful. Do we have this? Oh shit. Apparently we don't. We only have that in Oh, we only have that in how do you call it? In the H header. Oof. Do you have it? Do you have the Win32 one? Oh, we actually don't really have Win32 either. Ah, you need to define. I see. So if def, right? The header has if def, so it includes the X11 shit. So yeah, it's like the user needs to define that. It's different. We don't need to do that because we are not in C. Right. So do we have this one? Nope. Anything else with xlib VR OpenXR? This is the H headers. Vulkan. Okay. We have something for generated windows. Why generated windows.jai has xlib surface info create? What the fuck? Okay, we have generated Linux something. Structure type info kchar. Xlib surface create info kchar. So I guess that's one. Okay, let's maybe see some example. Vulkan kchar xlib server. What's that? This is just a protocol. Oh, it's extension. What's that? Oh, can I make the font bigger? Can I? Why is it? Oh, it's the page with an entire spec, right? This is like an entire spec in a single HTML, so it cheats itself when you try to render it. The infamous Vulkan spec that no browser can handle. Oh my god. Oof. Yikes. Disgrace. Like, browser has one job, render HTML, and you can't even do that. In what year are we living? Native platform surface or window objects are abstracted by surface objects, which are represented by VK surface KHR. What does KHR stands for? Is it Chronos? Just like a self-inject for the Vulkan committee? Oh my god. I just tried to increase the font, so maybe people on the stream can read it too. But apparently you can't really do that without a web browser shitting itself. And I wouldn't even say that, oh, it's gonna work better in Google Chrome, because Google Chrome usually has worse performance on Linux, at least for me. Okay, 160. I just want to do it so that the left panel disappears. Okay, we'll let it settle. Okay, and now we'll press enter. Yeah, there you go. 2025, year of web browsers. What the fuck is this? I had a fun moment today with the Windows terminal and Focus fighting about. Is it like when you do like set foreground window, and they probably just try to set foreground window themselves in a loop or something? Okay, native. Yeah, I read that already. You could use inspect element and delete it. Nah, Mr. Semi Hacker. Hello, welcome to the stream. Why would I do that? If I do that, then I don't have you know, an opportunity to complain about browsers being bad at their job. Where's the fun in that? Also, like, I'm not gonna be surprised if I open inspect element and like the entire browser fucking crashes. Because there's too much tree to parse. But yeah, I mean, as soon as it's rendered, it's kind of fine. Yeah, so surface, but this is like surface create info. Ah, okay. So this is Android. Wayland. Okay. Win32. Okay, okay. Do we have X11? XCB almost. Xlib. Let's go. To create VK surface kchar object on an X11 window using the Xlib client-side library call. Okay, we're gonna call this. Right. Instance is the instance to associate the surface with. So we need an instance, right? Window is, well, we have window already. Surface create info. VKXlib surface create info kchar. So since it was able to autocomplete, and the Emacs has hippie expand like built in, it's just like word-based autocompletion. It means that it found, I would say it found and detected it somewhere in the buffer file, which means it exists in the bindings, but no, it literally got it from here. Yeah. Okay. I thought like, oh, it's probably bound. Yeah, all right. Right, so surface create info dot s type equals something something. Yeah, let's instance is the instance to associate the surface with. P create info is a pointer to okay. Where where's the instance? Oh shit, where do you get an instance on X11, I wonder? Is it like just a display or probably maybe a window? Okay, let's not worry about, let's not hurry. Let's just read the spec. Read the specification, young Skywalker. Yeah, create info is a pointer to the create info structure containing the parameters affecting the creation of the surface object. Allocator is, yeah, allocator, obviously. P surface is a pointer to VK surface handle. Oh, the surface is probably, how do you call it? I mean, maybe it's just a window, but maybe it's the gravity or like graphics context. Maybe it's like Xlib graphic context. Hey Dunka, hello, hello, welcome to the stream. Hello. Thanks for tuning in. But yeah, VK surface kchar. Valid usage. Instance must be VK instance handle. Vulkan XML part of the stream. So Jai ships with bindings generator for Vulkan, but it uses headers. So maybe, yeah, maybe we'll just do that. I'm you know, you can only do so much XMLs per week. Ilionte. What's up? So there's this shit called Vulkan, which is like graphics API, you probably know that. And Jai, the programming language, ships with the Vulkan example. But this example is only kind of built for Windows. And it has like a points, platform dependent points. And the Linux version just isn't implemented. It just has like a to do and assert false. So today I'm trying to implement it and see what this example looks like. And of course, I'm a very well-known Vulkan expert in Vulkan community. As in, I don't know shit about Vulkan, so we'll learn it together. I may or may not be messing with you. Nah, I mean, knowing you, you're deadly serious because, you know, you're like enterprise certified Java applet, Spring dev boot developer. So surely you're very serious about your XMLs. I have no doubt in it. VK instance. I guess VK instance is... Hey CTPP, hello, welcome to the stream. I have never done Java in my life. I only use C#. How can I talk to you after that? Not Java, C#. Yikes. Okay, let's open that in the new window. And valid pointer surface kchar handle. P surface. Okay, let's open surface. I don't want to spoiler you if the quest is to do Vulkan things, but I posted my version of modules Vulkan that works on Linux in the Discord. Damn, I just can't not look. Oh, you posted it to you posted it on the Google Drive. Yeah, okay. I'll try to do it myself, and if I fail at any point, then I will just steal it from you. Anyway, but yeah, hello. I mean, the ultimate goal is to learn something about Vulkan, right? Mostly Android changes, but the Vulkan module is there modified to work with Linux and Android. Okay, yeah, thank you, appreciate it. So yeah, the overall kind of idea is to learn something about Vulkan. Maybe not to become like a super expert or anything, but just to kind of become familiar. Yeah, I'm genuinely interested in learning some stuff about computer graphics, but I haven't decided if I want to try Vulkan or maybe just try software rendering first, just to learn, more about concepts before I just dive into APIs. So we'll see. Yeah, that's partly, yeah, okay, I mean, that's fair enough. And also, since my overall productivity only works somewhat when I'm streaming, that's why I stream it. Because like after work, it's so hard to force myself to do anything that I literally have to stream, so I have any sort of accountability because people might be watching. Otherwise, I'm just too low energy to do it. Have to stream to keep yourself. Yeah, otherwise I will just spend the entire day watching YouTube or other streams. Yeah, so streaming is very good for accountability. Yeah. Xlib. Huh. Yeah, there you go. This is it. This is it. Yeah, this is literally it. Oh, yeah. Okay, I found it. That's the struct. VK structure type. So S type is VK structure type. I guess this is an enum, right? S type must be this. Okay. So this. Do we have it? Holy shit, we have it. Look at this. Epic. We have it in generated Linux. Ultimately, I want the XCB version, yeah, but since the examples in Jai come only with xlib bindings, I just want to do that. So, maybe we just can submit it to John so that example in the modules has it. But for my personal stuff, I would definitely go with XCB. I don't want any xlib in my fucking code. Fucking xlib. Whoa. Firefox goes crazy on this page. Or maybe this is my mouse wheel just keep dying. Pnext. Pnext we probably don't need. What's next? Flags. What are flags? Do you have something? Pnext must be null. Okay. Flags must be 0. That's absolutely perfect. It's just yeah, the most beautiful things. It's funny how it must be null, but they even defined a separate type for it. The silliest type fields should already be filled for you. I mean, yeah, if this must, you know, must, they should be. Right? Yeah, because Jai has the default initializers, right? So yeah, we can, you know, if I mean, if you look in the generated Linux, they are they already are. Wait, are you looking like here? No, this is a header. Xlib surface create info kchar. Is it this one? Oh no, where is it? Where is it populated? I mean, I see the constant, but I don't see the structs being initialized with them. Or is this what you mean, that they just have bindings? Most structs have the S-type default initted for you. Yeah, that one doesn't. And I think, so you see how Windows extras, yeah, so you meant something like this, right? Right, so I guess Linux doesn't have that filled in. Yeah, I mean, we can do that ourselves. It's no biggie. Interesting. But you still set the S type, even though it's already preset here. In your version, it's now generated. Yeah, so I guess you just modified the bindings. It's okay, it's all good. So flags are 0. Now display, this is easy. I bet info.dpy is just x global like display. I bet that's the case. DPI xlib display, yeah, and xlib window. So yeah, surface create info.window equals to, well, window. Yeah, that's our info. Easy clap. What's that? Can close that. Can close that. Yes, so we have result equals to vk create xlib surface kchar, and we pass in the instance. Do we have an instance? Where does it? Is instance a global? Oh yeah, it is global. Okay, fair enough. So pass in the instance. Then we pass in the create info, which is a pointer to surface. Create info. Then we pass in the callbacks, which is null and surface. Wait, what is the surface? Is it also global? Turn result equals success. Yeah, surface is also global. That's fair enough. Okay, so now we'll probably fail to compile because this, not this. This one doesn't exist, right? Oh. No, because we don't have semicolon. Yeah, error undeclared identifier. So we need that. We need that. Where do we put it? So there's like generated Linux. It just has a bunch of, what are those? Opaque structs. Yeah, so here is a bunch of wrappers. No, these are enumeration helpers. So do we put it here, or do we just make them make them be like generated from here? So I think for Windows, there's nothing really special for Windows here. So they just literally baked that in. What do we have here? If Windows, we have some kind of Vulkan 1. Win, lean, and mean. I've seen that somewhere. Visitor, Vulkan visitor. What do you have in Vulkan visitor? Okay. VK result. Flag bits, base surface. Maybe add enumeration wrapper. Okay, so these are enumeration wrappers. We can, I guess, add the same for create info structs, right? Don't crap as much over the global namespace. I don't need every feature in Windows ever. What do you mean? You don't need this create com object W? What do you mean you don't need that? Of course you need that, you just don't know it yet. Yeah. Type default value, some struct name. Oh, this is also one. S-type. Maybe that's the one? This looks like it does something that we might need. Enum value name. No, this is just gets value name. Set the default value for S-type. Base init, base output. So it's very kind of very targeted. Right, only if the parent decal name is this or that. Okay, I guess I can just let's see where this one is. Define. This one is defined in Windows Extras. It also it's also in modules. Interesting. So is this is probably yeah, this is probably typed out by hand. Yeah. So we can just do what? VK create Win32. VK create Win32 surface, yeah. This one doesn't exist at all then, right? Yeah, this one doesn't exist at all. So I guess we'll just, for now, do scope file, else if load, and we'll just do this. Instance vk instance p create info. This is gonna be, how do you call it? Win32 sir. So this one will be this one, like a pointer to this. Then p allocator is pointer to vk allocation callbacks, and p surface. Oh fuck me. No. Surface is pointer to vk surface kchar. Yeah, and it's gonna, dude, fucking Emacs, can you please don't do that? Result is foreign lib Vulkan. Yeah. Cool. So that's gonna be it, and then this. So this one is in Windows Extras. We don't have Linux Extras, right? So instead we can do what? I guess I can just put that into the main Linux file. I don't know if I should really create like Linux Extras. It doesn't feel right to me. Those extras. Yeah, because this seems to be generated by hand, you know. Or do we create Linux extras? Now let's just no, because generated because generated Linux will be completely overridden, right? So it's like not safe to modify. So we will create extras.jai, and this one will be this info kchar struct. So this is gonna be that. P next void pointer and equals null, right? Flags and equals null, but I think I closed it, right? Oh god, okay. Oh shit, dude, it's really gonna poop itself. Xlib surface 3, no. Oh wait, I needed to click on the Xlib platform. Xlib, yeah, here we go. Let me click on the header, please. Nice. Did it click? Okay, yeah, it clicked. Epic. Pcreate info should be a pointer to this one. Can I? Okay, open it in a new window. Nice. Ooh. Come on. Come on. Yes. No, no. Something is loading. Okay. Yeah, pointer to void. Nice. Flags is this type. It must be 0. It literally must be 0. Right? Then H instance, this must be display, or I guess it's like X display. I don't remember what it's called. Is this X display? No, it's like display. Yeah. And window is, it's DPY. Is like window. Yeah. Hell yeah, brother. So that's the one. And we need to load if Windows import Windows. Where is it getting, where does it load? Oh. Generated Linux and load Linux extras. Yeah. Hell yeah, brother. And else if OS equals Linux, import like just straight up X11. And let's compile it again. And valid top level, what? Oh, whoopsie. Nice. Undeclared identifier display. Wait, I literally loaded. Is it not how it works? Because I assumed, so this file is getting loaded into, oh, do I need to, wait, do I need to import? Generated. Do I need to import? No, it doesn't import the Windows. Only basic. Where does it? Let me go to window extras. Yeah. It doesn't import Windows here. Oh, it does. Fuck. Okay, so I need to go to the scope file and do the same. I just want to be kind of consistent with... yeah. Oh, shit. Young from Killring. Yeah, this and Acceleron, right? And then example. I guess maybe I don't need it here. Yeah, so undeclared identifier of VK, xlib, surface, create, flags, kchar. Huh. Weird that it doesn't exist here. No way. Yeah, it just straight up doesn't exist. Huh. In which header is it defined? Where is it defined? It's like type devs. Provided by VK kchar xlib surface. Is it because it's like in an xlib header or something? Let's source. So there's VK platform. What do you have here? Do we have? No, this is just some type devs. No biggie. There's like core. There's like Win32 crap. There's some like create info for Xlab, and that's it. And here you have that Win32, Vulkan Win32. I assume. Oh, was it just like generated from system headers? Doesn't look like it. So Vulkan location. That's all you have. Just literally Vulkan H, Vulkan.h. That's literally it, right? I shouldn't have done this. No, it's fine. Actually, it's fine. Where did it get Windows stuff? Did they just added it by hand to? Oh, it's probably just like a. Yeah, literally this. So it's just by hand. Okay. I mean, I can do that. Linux extras. So this is VK flags. Yeah. Hey, look at that. We're compiling. Windows Surface creation failed. Module example. Is it? So this failed. Was the result not success? Result error extension not present. What? Do I not have Vulkan extensions or what? Where do we have like? Oh, print available extensions. Okay, wait. Here, Xlib Surface. It's literally there. What do you mean? Do I need extensions somehow? Application info, no engine, make version, instance create info. Oh yeah, okay. I knew that. I fucking knew that. You know, I work with C-based APIs for a while, and I literally have an intuition over how they're structured. I knew you fucking need extensions somewhere. So this means extensions, if not debug. So we have 3 instead. We have surface extension name data and extensions 2 equals vk khr xlib surface. Do we have? Where is this? It's in Windows fucking extras. Fuck. And there's some surface spec version and surface extension name. So we need the same for Linux. I think we have it here. Ooh. So Vulkan xlib surface extension. Yeah, there you go. What is it called? I just need definition, motherfucker. You motherfucker. Okay, yeah. So this is the one, right? This is the one. What is it called? Spec version. Boom. And I guess this. So extension number. So this is 5, I assume, right? Version is revision, right? And this I assume is gonna be xlib. I'm just literally like winging this shit. But it's pretty intuitive if you ask me. Okay, so we do here surface extension name. Then xlib surface extension name, that data. I've gotta go. Yeah, thank you for the good luck. I really appreciate it. There are 2 buffer overrun bugs waiting to happen in that example, in case you start getting weird crashes. Thank you. That's actually appreciated. Buffer overruns. I am afraid of any buffer overruns. Fucking eat them for breakfast, or rather they eat me. But anyway, yeah, I'll try my best. Oh, I renamed Win32. I shouldn't have done it. That data. Now there's gonna be 3. So surface extension name and debug. Yeah. So now there's gonna be 4. xlib. So Win32. This is gonna be 3. This is gonna be 4. Wait, what? Oh. Yeah, you can't do that at the same time. Well, it's like 3. If not debug. This is like weirdly structured. Maybe the first one, you mean this one? Was just ported from define name 1 just to define the name and value, doesn't matter. I don't know. We'll see. Yeah, I mean, we can cross-check with... I assume if I just do Win32. Yeah. Ah, shit. Yeah. Right, so... Right, this 1 and 5. But they definitely don't match. Where do you get them then? Or maybe this, maybe here in the spec. No, also have like registered extension number and revision. Well, the name string I got right, so this is the name string. Enum. Keyed mutex. Description. Do we have like values? No? Where do I get the defines then? So if I just Google for that. Oh, I have Vulkan xlib. Well. Yeah. So it's just 1. So I guess it's whether it's like defined or not. Right? Ah, it's a preprocessor guard. So you probably don't even need that at all. Right? But spec version is correct. Spec version is 6. So yeah, this is just like a guard. Guard. I mean, xlib header is extremely slim, to be honest, right? I can just have it on the side. That's probably nice. Yeah, okay. We take those. Let's just rewrite this. So instead of having this weird like not debug, we will just have so if OS equals Windows, right? Yeah, I see why they did that. No, let's leave it at that, but have an additional if else here. So this is gonna be 2, right? First one is this one, and then if OS equals Windows, then we'll have that. Else, if OS equals Linux, we'll have this. Yeah. And same kind of here, else if Windows, then we have that. Else, like if Linux, then also 3, and we have mostly the same. Xlib and debug. Yeah. We can even have that outside of if else, right? We can have that. So now that I did that, can we? Okay. Hey, look at that. We probably correctly initialized the surface, right? Now we have invalid memory locations. Ooh, not this one. Let's close this and check that out. Somewhere inside libx we failed. In init surface. Huh. That's interesting. Init surface. So somewhere here. Oh, it's not even in. Right, it's not even. We didn't even get out of here. I wonder why. Invalid memory location. Faulty address is. So we have a crash inside of. So did we not get a correct X connection or what? Is one of those not right? Create window. Available extensions. I mean, that should be fine because I'm pretty sure create window returns me a window on X11. Yeah, it does return like X window, right? So we do global display lock SWA blah 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 map window input context array add, and yeah, we just straight up return it. Yeah, I mean that should be fine. I wonder what it doesn't do. Do I need to lock display before I do that? Before I need surface? I don't think so, but let's try it. No, it didn't really help much. Didn't help much. Ooh. Right, so it's funny that we didn't even get like any validation errors, we just straight up segfaulted. I don't think I have debug symbols. Oh, we can't get XCB connection. Look at that. So this is why I don't like libx11 at all, because these days it's just like a wrapper, like an abstraction compatibility layer on top of XCB, which is, you know, actually does all the heavy work. So in the old days, libx just like raw dogged the protocol, but then as usually goes, it became like bloated and unwieldy, and people around like 2001 2003 came up with the other library, which is basically just a very lightweight, straight up bindings directly to the protocol calls, which is called XCB, something like XC bindings or something. It has like cute cat mascot. And then instead of throwing libx11 away, what they did is that they throw out some internal parts and they rewrote it to XCB. So now libx11 is written on top of XCB. And now it segfaults somewhere inside when it tries to get internal XCB connection, but it can't. But it cannot. That's why I don't like libx11 so much, because it doesn't even do anything, you know? I mean, it has like double buffering of events, and, you know, it serves a compatibility for all that software, but these days you really shouldn't probably use it. But yeah, let's research. Maybe we fucked this up somehow. Like display window, and then we do that instance. Surface create info, null and surface. Sounds fine. We didn't set flags. What if I do that? It didn't really change anything, but oh. Wait, what? Why didn't it change? Why didn't it find it? I don't understand. It's literally here. Oh. Ooh. Yeah, this one. Yeah. Monka. My Emacs is... What the fuck? Emacs is dying, everyone. Hey, work harder, comrade. Flags is reserved. I mean, it's just a type alias, right? So I don't set it directly. No, it does. We don't. What the fuck? Why does it delete shit? Oh my god, my Emacs is dying. Camera is dying. Wait, is... Maybe, you know what, maybe it's not like Emacs, maybe it's Vulkan is killing my computer or something. You know, I'm trying, because... Hey Yarik, hello. Path of Perpetual Torment, yeah. Again, not focusing? Oh, it focuses, it's focused now, I see it. Yeah, maybe Vulkan is bricking my GPU. I think we're fine now, right? Yeah. Yeah, we're segmentation faulting. Let's check if we are correctly initializing extensions. Print available extensions, init Vulkan. Let's see if we do this correctly. We make version, instance create info, application. If not, we have debug probably. if Linux vk-char xlib surface extension name that data. Do I use these correctly? Yeah, else if. Okay, yeah, I use it correctly. vk-char xlib surface extension, yeah. Yes, Sergey Abdulov, JICE tracks are 0 by default, that's right. I mean, there is a, hey Bifask, there is a cool streamer, Provat, on Twitch. He regularly streams like very advanced Vulkan crap, like ray tracing and whatnot. And he has a counter on the stream by how much time Vulkan crashed his GPU. So from time to time, he would actually like bsot or like kill his machine while doing some Vulkan stuff. So I actually saw it happening multiple times on his stream. So there's literally a counter. Yeah, I mean, that's annoying, but I guess that's... I mean, if you think about it... Hey, pretty, hello. Usually on Windows it recovers. I mean, I don't know if it recovers on Linux. Like, if it actually like cucks your computer so you have to hard reboot. I'm not entirely sure if that's the case, but yeah, it definitely crashes the stream. But the drivers on Linux are usually less reliable, that's for sure. And if you think about it, like GPU crash is kind of like seg fault. But if you crash your entire GPU, I don't know. I don't know anything about how GPU works. Right, so it's probably not like BSOD, so it doesn't lose like your entire state of work. But yeah, on Windows, when GPU driver crashes, I mean, when I stream and GPU driver crashes, yeah, when I stream and GPU driver crashes on Windows, sometimes my stream dies, and I mean, usually it dies. And I have to restart the stream. But yeah, the system itself recovers. AMD drivers on Linux are extremely flaky. You can crash. Yeah, shit. Yeah, I know about timeout detection and recovery. And actually, I had to increase the timeout. Because otherwise the driver would crash too often. When it shouldn't really. But anyway. Maybe something is like missing here, right? So we have extensions with the case surface extension name. What's that? Yeah, this is a sock. This is my epic pop filter. I'm a professional streamer. It works okay. Yeah, okay. I mean, this should be fine, right? We just add some debugging stuff. Yeah, this should be fine. We have a count and the names. Should be fine. If debug create info. Debug info. Yeah. It doesn't seem like... Yeah, I mean, this looks just fine to me. And it doesn't print any errors. Let's see if debug... Yeah, debug is true. If we set it false, it probably should still... Oh. What? KK char win32. What do you mean, not defined? I just literally said debug and it stopped. Huh? Actual product here. How is it not defined? What the fuck? If only Vulkan. Yeah. Is it checking debug somewhere here? Well, first, how is it checking that at all? Oh no. Oh no. Emacs is well, bye, I guess. You fucker. Oh, I'm an idiot. I did that. Yeah, that should be fine, right? Yeah, okay, it compiles. Boom. Yeah, we're crashing. Fine. So, regardless of whether it's debug or not, we are still crashing as fuck. I mean, I don't know what to do. I mean, I can run debugger and see maybe like Linux display. Also, why don't I get the window even like flashing, you know? Maybe there's something actually wrong with it. So let me bust out the debugger. Yeah, let me bust out the debugger in projects, third-party joy modules. I'm sorry for the flashbang. Vulkan examples open. Yes, GDB time. Ooh. Run and debug. I forgot how to do this from scratch. Is it like LLDB? I cannot debug because... Oh, dude. Okay. I'll just copy it from another project. From here. Yikes, dude. So we have GDB launch, this one. Launch workspace folder example. I think that's it. Yeah. Bitch, can you run? Okay, we can. Nice, we have an exception. So let's check it out. Global display, something, and window, something. Is it good? Is it fine for window? We have, yeah. I mean, usually you would have your window already displayed here. Don't you not? Yeah, maybe it's not mapped, but why would it not be mapped if I just call create window here? Yeah, let me just crash here and step into create window, because I would expect the window already be here. So we'll have this, we get display, we get that, yeah. Dude. Oh, fuck. Is this why? Because it creates a fucking OpenGL context right away? Dude. Is this why? Yeah, it definitely might be. I totally forgot that it just fucking hard codes JLX, OpenGL nonsense, like right there. Let's get rid of it for now. Let's see if we can window creation Linux. So we don't want this. We don't want this, and then VI. Yes, not color map, right? Where is CMap? Background color, X color, alloc color. I don't think we need any of that. Probably. Let's compile SWA color map, background pixel. I don't think you need to really do anything here. Depth. Can you just do like 0 or something? Visual. Just hack this motherfucker. Not enough arguments. Oh, it's like 0, whatever. Type wanted visual null. What? Still crashes somewhere here. Anything else? Oh, I need a visual. Okay. Yeah, where do we get a visual? Visual. Wait, where's visual? Oh yeah, here. So can I just let me check. Can I get visual without GLX? Let me just get some examples of X create window. Yeah. Let me do it somewhat like this, so you don't get flashbang too much. Visual. Specifies. Oh, copy from parent. Yeah, that's what I can do. Just give me an example, motherfucker. Example, please. No OpenGL. Okay. Oh, there you go. No, not simple window, dude. Yeah, there you go. Window visual, which is... Oh yeah, it's just literally copy from parent. Okay. It's literally copy from parent. Copy from parent. Is it okay? Argument dereference of type S64, but it is... So can I not do this? Window depth. It's all copy from parent. So it's like copy from parent. Do I have it first? It's literally just 0. vi.visual. What? X get visual info. Or maybe we can do that. Yeah, maybe we can do that. Let me run this again. Wait, what? Oh, it's my program. Wait, never mind. Let me close it. And maybe let me get like here, straight up here. Yeah, we have some kind of window. It's the same number, I think. Anyway, store name. Class hints. Blah, blah, blah. Map window. Nothing happens when I map my window. Interesting. Huh. Why would it not just work? Hey Robo, hello. That's fucking insane. Okay, let's get visual info this bitch. X-axis autocast is just basically cast to whatever type is expected. Obtain visual info information. Yeah. Returns a list of visual structures that have attributes equal to the attributes specified. But if I didn't specify anything, display value info mask template. What? Okay, so yeah, I see. Okay, let's go. VI is X get visual info and X global display. Excuse me. Visual screen mask. What's next? The info template. What the fuck is this? And number items return. Returns a list of visual structures that have attributes equal to the attributes specified by the template. But it's dumb. I don't even have any templates. What the fuck? Ooh. Yeah, so let me just, I mean, this motherfucker just copies everything from parent. And it just works. Info with events. I'm gonna lose my patience, I think, in like 20 minutes and just rewrite and just write it with XCB. Something tells me. What's that? It's just useless. Can I just... can I just pass a pointer to an empty struct? I can probably just like post get like an empty struct here. So info is like x visual info, right? And I pass here just pointer to info, and I guess 1, right? And this, oh, what was it? It was vi dot like depth. Ah, shit. Let me just undo a bunch of stuff here. I'll copy that, and then I'll start undoing stuff. Vi depth with vi visual. Yeah. Paste it back. Visual screen mask. What was it? Shit. Visual screen mask. It's just that. It's probably defined somewhere that we don't have. Visual screen mask. Where do I have it? Yeah, here. Mismatching level of in direction. XX, this motherfucker. Oh, and now we're crashing and create window. So we did something. We did something. Oh wait, there's okay. Yeah. Type wanted count. Wait, no, count and pointer to count. Hey. And it's back to segfaulting. Info.screen. Yeah. I you're too slow for me. Racheto. Hello. Info.screen is the default info. Okay, yeah, that makes sense. Info.screen equals to yeah, screen. Yeah, this one, the default one. No, it still segfaults inside of the XCB connection. But why don't we even get the window like even blink a little bit? Because map window should just display it, right? Yeah, all we literally all we need is to, like, create window with the name. That's it. That's literally all there is to it. Huh. Like anything else? There's also like color map. I think that's like, we don't probably need it. Background color probably needed it. We probably don't need it either. Huh. Okay. So let's like go back to basics and make sure we like see the window at all. Actually, I can go to probably like examples or something. Yeah, and I can just do that. I can just literally comment all of this out, update window events, and I cannot even like don't even draw frames. So we don't even see window appearing on the screen, you see? Right. So window b linux.jia. So maybe it's a color map. Wait. X create window C. So background pixel. Let's just hard code this motherfucker. Background pixel. Where is it? Where do we set it? Like here. This is like set window attributes. Yeah, window attributes background pixel. It's like SWA. No, still no. Any color maps? No, there's no color maps here. Look at that. Yeah. So we kind of an attribute mask, because yeah, that you like send an attribute mask. Yeah, we just need like a back pixel. So let's do CW back pixel, and we don't have color map. Oh, we don't have it? What? What do you mean we don't have it? One. What do you mean 1L? What does 1L mean? Can you fucking write normal numbers? What does this even mean? What the fuck is this? Long. Is it just like one? Yeah, it's just literally like one shifted by one. Hey, look at this. I think long on Linux is 64 bits. Or no, maybe long on Linux is 64 bits. I actually don't know. Long on Linux. Always 64 bits? No. Look at this. Look at this. Where is it? Long. 32-bit signed integer. So not always. On 64-bit Windows, long is 32 bits long. Yeah. And you have long, which is actually 64-bit on Windows. But I think on Linux, long is 64 bits, no? Anyway, didn't know, don't care, we got our windows. We got the window running, so let's go back to the example. And then uncomment it. And see if we're still crashing. Oh, this is a comment. I saw a fucking window! Let's go! Let's go! Oh, but we're still crashing. It didn't even matter. We still crash. Like, I saw window just like blinking for, just like flashing for a brief second. And then we crashed again. You might need that color map, you think so? Yeah. Yeah, Windows is special. So you think I might need that color map? Okay. Hey. Yeah, let's check that color map back. You created in your Vulkan example. Okay, that's interesting. Where do you get color map? Is C map, and C map is X create color map. So like that. Nope. I think we didn't even get our window flashing. Can it be some X Wayland bullshit? Because, you know, I'm running on Wayland, not really on X11. I did put it. Did I not? No, I did it. I did it back. Yeah. Here it is. Oh, what the fuck? What the fuck is this? Ah, I just accidentally, yeah, did something. Wait, let me do that. Thanks for the clip. I don't get a window anymore. So with color map, I don't get my window. Can you create XLib? Yeah, you can. You absolutely can. Like, I have a whole application running, like, running in OpenGL with XLib. So, but if you're asking, can you create a Vulkan surface with XLib on Wayland? I mean, you should still be able to, right? Because, I mean, there are video games. Like, there are video games running on Linux, right? That definitely use Vulkan, and I mean, like, Wine runs them on XLib, so it should work. Like, if only I had some, like, information from maybe some debug layer, but no, there's like AMD driver. So if you look at the stack, I mean, I commented out, but if we looked at the stack trace, so there's like AMD driver, there was like Vulkan AMD is calling out to libx, that calls out to XCB, that in turn segfaults. So AMD driver is sending something invalid to X library, and it doesn't handle it. Instead of returning an error, it just segfaults. What the fuck? And we don't like. Oh, so what I do now is just I'm just speculating. I'm just putting a random shit in the code in the hope that it works. In hopes that it works. Right? I thought that, okay, the way GI window in module structured is that it literally hard codes creating OpenGL context when it creates a window, and I thought maybe that's the issue. You know, it's not necessarily creates an OpenGL context, but it sets up a visual with JLX constants, right? Right, and I thought that maybe that's an issue. What's that? Let's do this. Also. Nah, really nothing. It does nothing. Yeah. So, what's that? Okay. We decided not to do background pixel. Yeah. I think this is fine. Right? What's this 0? Let me see the... Where's the parameters? So display window. It's parent window, then XY, then width, height, then border width, 0. Wait, what? With height, then unsigned int border width, 0. Unsigned long border. It's a simple window, fuck. window, then depth, then class, and visual, and value mask, and then attributes. And our attributes is, yeah. Oh, background pixel. I need to remove that because I don't send background pixel anymore. I mean, it doesn't help still. But at least we don't really like screw up the parameters themselves. We don't have background pixel anymore. But we don't get the window showing. Maybe it's because of get visual info is not correct or something. Huh. Let me see libx Vulkan example. Basic samples. I'm sure it's gonna be awful. Let me set a dark theme so I don't flashbang you, my dear viewer. My dear viewer. Because I love you so much. I'm gonna try to flashbang you a little bit less. Linux build. Huh. Look at this, libwayland. Bruh, can you show me fucking code? What is this? Bro, what the fuck? Let's create window. There's literally no such thing in this entire repository. So Google just returned me a bunch of nonsense as usual. You just can't. You just literally cannot find anything on Google. Right? xlib Vulkan example in C programming language. VK test, okay. 7 years ago, seems legit. Main. No? Seriously? What the fuck is this? Bruh. OpenGL step-by-step introduction to Vulkan. Doesn't look good enough. Yeah, I mean, yeah. There are like, yeah. I'm sorry. There are just no examples of X11 code with Vulkan on the internet. Yeah, there's literally no. Okay, let's go to the second page of Google. Linus Tech Tips, Vulkan tutorials for C. Let's do this. X create window. We put it in quotes. Okay. X create window. Ooh, look at this. It has both backpixel and the color map. So, all right. Just read the manual, bro. It's so easy. Yeah. So we have init global display. Yeah, that's all right. Visual screen mask. What's that? Info template equals something something. We have that X visual info, right? Template screen, default screen. We have that. A pointer to info. Oh shit. Wait, what? Ah, no, that's fine. Yeah, that's all fine. We do this. X get visual info. Display. Visual mask. Yeah, it's visual screen mask. Yeah. Like I know that this is the value. Okay. Info template and number of visuals. Yeah, we get them. Sure. Color map. X create color map. Display. Parent window. Wait, root window. Oh, is. Oh, wait a second. Oh, this is a window. This no. Wait. Screen. This is not the parent. Parent is a window. I mean, it's a screen. Guys. Okay. What? No, it's all good. It's all fine, right? Create. No, it's all good. I was doing everything right. I thought I did something wrong, but I did everything correctly. Visual screen mask. Yeah. Where were we? A screen. Let me make font bigger so you can read. Visual info. X get visual info. Display. Mask. Pointer to template. Count. Cool. Color map. X create color map. Display. Parent window. Right? Here. If parent none, then parent equals root. Root. Yeah. Okay. That should be fine. Because it works with OpenGL, right? Yeah, then visual info visual and alloc none. Cool. X window attributes. Yeah, these are, here are they. Color map. Yes. We can do background pixel. We can do both. I'm not opposed. It's okay. It's gonna be white, but it's fine. A border pixel. There's even that. I don't want fucking border pixel. It's impossible to find things on Google unless it's something very popular. Yeah. Yeah, event masks, this is okay. X create window, display, root window, width height. What's that? XY, okay. Width height, then 0, then depth, input output, visual info. Then you have back pixel, which was something like this, and right. Color map, window attributes. Okay. Can I? Okay, so I can create window when I have a back pixel. There you go. Now, if we go to example and we uncomment this. I mean, if it's gonna segfault now, then I'll just assume that it may be some, no, it's still segfaults. Still fucking segfaults. Let's maybe do that, like, like, X Wayland, Vulkan, segfault. Segmentation fault during EGL initialize. Something that's closing the connection. No, the init crashes, like literally init crashes. Wait, not init, but init surface crashes. So VK create xlib surface KHR crashes. So we don't even get past that, right? Yeah. We don't even get past that. What can even close X connection? I mean, I can't see anything like trying to close it, right? Maybe something here, like when we init Vulkan, but I don't know. So I initialize, right, extensions. I initialize that. Extension name and xlib. I mean, we have debug, so it's like xlib and then debug once, right? Yeah, and we don't get any errors here, so I assume it's all just loaded super successfully and we're all good. Yeah. And so in init surface, when we call create xlib surface KHR, we are seg faulting. I mean, not we, xlib seg faults. Segmentation fault attempting to run. I get XCB connection. Yeah, this is the one. Probably. No? Yeah, so here. Let's see what some random GitHub issue is trying to. Oh. Try calling xlib get xcb connection yourself before you do the VK surface stuff. Yeah, that's a good point actually. What does it accept? Oh, we don't have it. Oh shit. What was it again? It was like x get xcb connection. Yeah. Do we have it? We don't have it. Let's see where it's defined. X get xcb connection. It just accepts DPI. Yeah, okay. Let's quickly bind it. Right, like it's DPY is a handle to like pointer to display, and it returns XCB connection T is like an integer. No, it's not really an integer. It's like that. It's an opaque struct, if I recall correctly. Right? Foreign and was it just like xlib or whatever it was? What was that? libx11, okay. Library system. X11. Let's define it above. Yeah, it was in device creation. Okay, that's good to know. That's good to know. X global display. Wait, what? Ah. What? Oh yeah. Unable to resolve foreign symbol inside library libx. Oh shit, what do you mean? Ah, it's in some fucking other library. It's like libx11 xcb or something like. Oh, okay. We flashed. Where did you crash? No, you see, it crashes inside libvulkan Radeon. Yeah. So we don't, when we call, we don't crash. So something inside libvulkan Radeon segfault xcb. What display you pass to Vulkan? The global one. The same one I pass here. So the X global display. It's not a pointer or anything, right? Let me just check if it's a pointer. If I am like being a super like idiot or something, because I mean, what if I am? Fuck. Am I an idiot? Dude. No way. Wait, why didn't it? Okay. Fuck. Why wouldn't it like? Yeah, whatever. Okay. I'll just forget. Yeah, I'll just forget it ever happened. What do you have in it? Fuck. Fuck. I wanna close the stream and never never stream ever again. Just remove my whole presence from the internet. I just wasted like 40 minutes by chasing that pointer. Alright! It was because auto dereferencing. Fuck. You'll be like, I fucking told you so. Auto dereference fucking sucks. Wasted 40 minutes because of auto dereference. It's because I fucked up when so I manually put the structure in, and display is not just display, it's a pointer to display, but I did that. Right. I did that. And so when I passed a pointer here, Jai did automatic dereferencing to an invalid address. Yeah. That's what happened. Yeah. Fuck me sideways. Okay, so we have a window. Let's go back to... let's go back and maybe undo all of that, and maybe it will just work with GLX, you know? Let me just back this up. Back this entire shit up. Somewhere here. And let's just gradually undo everything we did here. Bloop, like that. And see if it still works. Success, physical device count 0, physical device count support queue, init render. Okay, yeah, something happened, you see, look at that. I mean, yeah, you know why window doesn't render when you create it? Because you don't give it like any background shit. So it doesn't render until it has a background. Right. Nice 2-hour adventure, yeah. I mean, the first hour was productive, okay? The first hour we spent adding more bindings, reading about Vulkan, having fun, and then, yeah, 40 minutes of this bullshit. But I'm used to it, you know? I'm a web developer at my main work. I do this literally all the time. If only the compiler could be normal, yeah. I don't know, I still think auto reference worth it. So what happened is that, let me kill the compilation process. Compile, I mean, but like, how do you distinguish it, right? So should you treat assigning to struct field differently than like regular assignment? So what happened, let me first say what happened. I bound this struct, right? vk xlib blah blah blah, and accepts pointer to display. But when I did typings, when I did the bindings, I just literally forgot the star here, right? This is what I did. And Jai has automatic dereferencing. So when I put a display here, it recognized that, oh, it's a pointer. So it just literally tried to dereference it, which was, of course, invalid. Yeah. 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 So you're saying that we can keep automatic dereferencing, but like, I don't know. Doesn't it like just remove all cases for automatic dereferencing? Like if all assignments, if you can't like dereference all assignments to pointers, or to like not pointers. Yeah. So can we like still somehow detect that? So can we still somehow have automatic dereferencing? I mean, because it's very useful, but prevent situations like that, right? So if you have a type, right, like, so you like, for now, we can do this, like, and you have like, somewhere you have this, right? For now, you can do that. So this is valid in Jai, right? And like under the hood, it will do this. Like this will happen under the hood. Right? And that's what fucked me up. So if it would be a compiler error to do that, it would yell at me. It would say, hey, you can't assign a pointer to something that's not a pointer. You know, it would say, what does Jai said? Like indirection error or something like that. A mismatched level of indirection, right? But the other way, it yells that when you try to assign non-pointers to pointers, it will yell at you. Or if you try to assign different level of pointers to each other. But this is legal for now. Like this is legal in Jai. And this is what fucked me up. No, I mean, essentially, right? And the entire reason to have automatic dereferencing in the language is that it's very, it's like very helpful for refactoring, because you don't need to rewrite, you know, this to like that every time you change from pointer to non-pointer. And yes, that's also a good point, is that usually like structs are not supposed to be wrong, right? Yeah, because I mean, I literally fucked up the struct. Like that was the mistake, right? That was the error. This This like wasn't, this was not the a source of the issue. The source of the issue was that I fucked up the struct definition, which is like a very edge case. Like, is it really worth, you know, removing automatic dereferencing from the language just I mean, of course, Ilionte will say that yes, it will worth it. It's worth it. It's like always worth it because automatic dereferencing was a mistake. You need to dereference manually. I know his point. And, you know, after spending like 45 minutes, I am even more sympathetic to this point, not going to lie. But tomorrow I will forget about this, you know, fiasco and we'll argue against that again. Anyway, let's maybe continue. Yeah, we have the init surface correctly. Like, not gonna lie, having to spend 45 minutes because I made this mistake, it didn't make me reconsider, but you know, I feel it more now. Even though I agree with the take that the struct should be correct in the first place. How did it dereference display? Isn't display a opaque pointer type? That's a very good question, Mr. Tax No Bucks. So display is only opaque struct if you turn a certain define in the xlib header off, because display can be opaque, but it can be not opaque. It depending on one define. And the way bindings are done in Jai is that display is actually, oh wait, no, actually I think, yeah, display is still yeah, okay, display is still an opaque struct. The screen is not opaque. Oh no, we have X private display. Yeah, so we have X private display from the headers. We have X private display. And yeah, so we have the definition of display. We just haven't like passed it all the way. But yeah, anyway, display is an opaque pointer, but automatic dereference doesn't really care about it in Jai anyway. So you can still dereference it. And I mean, from the point of view of the language, it's right. It will be some kind of a whatever memory it is. Like it's just like holds an address. So it's like whatever. When it generates the stuff, it will just generate another number, I guess, or whatever it is. Actually, I wonder why it didn't go all the way. So we have like a private declaration for the display, right? X private. But we didn't pass it like there. Interesting. But we have a screen, right? Yeah, so ximage is exposed, right? Ximage is exposed. This is also supposed to be an opaque struct. At some point, I lost 1 hour to xcall. I mean, that's like a completely different thing, right? So yeah. So what I was talking about. In vim/user include x11. Let me make the font bigger. What do we have here? Do we have xlib.h? Yeah. And the way it works is normally where do we have display? Display. Yeah. Screen. Yeah, X display. Struct display. Yeah. Look at this. No tux. No tax, no bucks. That's a cool username. So normally, and I guess in the most places, this stuff, xlib illegal access is not defined. So you get the opaque struct display, right? You don't get it. But if you before you compile, you define xlib illegal access, you actually get access to the display structure and you can use it. And it's even like somewhat documented. Here it is. You can get it if you want. You're just literally one defined away. So it's, you know, not whether it's opaque or not depends on, I guess, the level of your perversion. Yeah. Anyway, we have init surface that we passed correctly. Then I guess we have init device, right? Physical device count, blah, blah, blah. I think it just works as it is. And then init swap chain. Where do we actually end it? In init render. Init render. Log init render. Okay. Oof. I honestly know like jack shit about all of that. I see some fucking semaphores that look at me from the abyss. And I don't want to look back at them. Let's just see what... you need to draw frame if you want to actually draw. We have a Vulkan. I am so cooked. Look at this, we have Vulkan running on Linux. And I actually don't have any buffer overruns. Yeah, I commented out a lot of shit. And those JLX initialized things, like JLX attributes, they actually don't even mess with us in any way. Here we have it. Monka, yes. My GPU is screaming right now. Oh. Two hours to battle the language. You're gonna roast me like forever. What was that? Was it like GPU top? I'm gonna let you roast me. I kinda deserve it, not gonna lie. What was the GPU top program? Was it G-top? It's no. NV, I think it's only for NVIDIA, right? That's a nice username, 127000. Localhost. NV top. Is it only for NVIDIA? No? Oh, it's NG top. NV top. GPU. Oh, AMD. Okay, that's for all of them. Nice. And I even have it installed. Okay. NV top. Yeah. Let's look at it. And it wasn't 15 minutes, okay. The first hour was productive. Fuck. That's unironically kind of embarrassing. Yeah, so GPU 0. Okay, this is the CPU. And it's like spinning at 75%. OBS takes a lot. An example, you see, look at that. I'm not actually mad, to be honest. Like it's okay. It's okay. Don't worry about it. Oh, I literally got lung cancer from this debugging session. This is beautiful. Let me enjoy this for a moment and wipe my face with my tears. Yeah, this motherfucker spins. Wahoo! Vulkan on Linux. Yeah, anyone who just arrived, we made Vulkan example work on Linux first try. with no effort applied. Yes. That's exactly what it was. You can go and rewatch the VOD. It was literally easy first try. Nice blinking. Nice strobing effect. Very elite, if you ask me. I think so. On Vulkan, correct me if I'm wrong, I heard something like that. To resize stuff, you need to destroy and recreate swap chain every time you want to resize, right? And I've heard that because of that, resizing in Vulkan is extremely like tedious and bad, right? And so resizing in Vulkan is like unsolved issue or something, right? Because so there was a guy who was like really into like resizing for some reason. You know, like how men go. Men would like pick the most stupid thing to be obsessed of, and there was like Ralph Rust resize or something. Yeah, Ralph Levin's blog. Do you remember this guy? It's like he wrote a text editor called Zai or something, and he had like a whole ass blog about resizing. Like he had a whole ass multiple series about resizing. Yeah, swap chains and frame pacing. Maybe that's one, or maybe resize. Yeah, the smooth resize test. Okay, yeah, there you go. This one. And he would just like go on and on about it. There was like multiple blogs from him where he would like say that resizing is just fucking impossible. Yeah. The conclusion somewhere here is like resizing is dog shit. He like literally says that. I forgot where exactly, but yeah. Oh, it's solved now. How did they solve it? Did they just allow you to not destroy your swap chains? Or what did they do? It's so satisfying to close a bunch of stuff. Oh yeah. Oh yeah. Yeah, look at that. Yeah. Cool. Solved. I mean, if it's solved, it's good. By the way, hi Foxy. Hello. So what do we do? We like just like submit this. It works only by recreating. We can't. Yeah, for some reason, why is on all operating systems resizing is so hard to do, man? You know what you have to do in order to get smooth resizing of Windows on Win32? It's just insanity. You either have to render in a completely external thread, or you need to introduce fibers to your code base. So you can yield the timer when you resize, so your main thread can handle the rendering. And if your main thread doesn't render within like reasonable frame rate, then you can't move your window anymore. It becomes choppy. And you know, and if timer spikes or something, you just can't move or resize your windows anymore. But the solution itself is pretty simple. So like it is a solution, but it has downsides. You could pre-allocate memory for bigger swap chain and then don't but how do you predict that? You won't allocate swap chain for every pixel, right? On Wayland, your window size is given by the size of your buffer. So if you want to resize the window, you have to reallocate the buffer every time. And if you're not using, yeah, you definitely need to use that like shared memory, like DMA buff or something, right? So you have like shared memory between GPU and CPU. Is that something? Yeah. Because otherwise you have to transfer it through the wire, right? In Wayland, that's definitely fucked. It's just unfeasible. But I think that's exactly why DMA buff got introduced, so you don't have to do that. Yeah. Like, just think about it. Remap. I mean, that's fair enough. Like, just imagine that they implemented a wired protocol for no reason at all, like, right? So okay, X11 was wired, that's fine, because you're kind of supposed to run X server on a completely different machine and connect to it with tiny clients. But Wayland was always desktop local. But for some reason they made it wired. But since it's so bad for performance, they have to introduce a workarounds so you don't have to talk to the wire. So yeah, the protocol is wired, but there's like a backdoor, like a memory buffer that you can write to. So you can have like a memory buffer you write to, and then you need to talk. You need to send commands through the wire. That's so stupid. Why can't you just, you know, call into code the same way you store your memory? Like, I don't know, man. But why do you need them to be messages? Why can't they be just normal functions that you call? Why they have to be messages? It's like, call the function, dude. And in libvalent you call functions, but it's just under the hood, it serializes the binary payload and sends it over the wire. How do you call a function in a different process? I mean, you don't. Why do you need to call it in a different process? Just like link to the compositor somehow or something. I don't know. Or maybe use, maybe like, I don't know, like use some kind of a, like maybe, you know, maybe there is some message-based protocol, but like it's completely like invisible to the user. I mean, how does it work on Windows? Like on Windows, you don't send anything to the socket. You just fucking call normal functions that return you structs or whatever. Do they use some kind of wire under the hood or what? I mean, there's like Explorer XZ running somewhere in the background like a compositor, but how does it work on Windows? There's surely like not a socket there, but somehow you can create windows or whatever. Right? I don't think they're like serialize shit and send it over the wire there, because like, yeah, I mean, but they definitely don't have fucking sockets laying around over there. There's just some syscalls that you do that create windows and draw. There's like literally a syscall for putting pixels on the screen in Windows, I think. There's like a, wait, there's like a guy on YouTube. What was his name? Win32. Draw like. There was like some. Yeah, Windows graphics programming. Drawing graphics with C and Windows API is easy. I think that one. Wait.
In this video, we're gonna draw some graphics.
Yeah, wait. Was it like this? I think it's what was this video.
On the screen using the Windows API. Specifically, I'm gonna use something that is called GDI, and GDI stands for graphics.
Where was it? This one.
And this will the window, which is gonna be the handled. Now I have the first parameter. Go ahead and save this. Specify.
No, it was, but it was on his channel. Wait. Let me find it real quick. By the way, he has like some insane content. Wait. I missed out of chat in YouTube. It's so sad that Plan 9 never appeared and enthusiasts had to use Unix. I mean, Plan 9 is even worse, that because it takes the everything as a file to its like logical conclusion. Where was it? Tiling window? No, not this one. Yeah, it's like deeply integrated. Wind. how window kernel draws
Let's
graphics.
take a look at
This
how
one.
Windows draws graphics on the screen.
Yeah, this video. Right, we can like I can show it to you.
Architecture of the main model that is in work over here. Over here at the top, you got the application that is wanting to display graphics on the screen. It has a couple of options of APIs, for example, Windows GDI or maybe Direct 3D. And we did take a look at Windows GDI on one of my previous videos. It's a pretty simple API that lets you draw simple graphics on the screen. For example, drawing a rectangle is very simple. You just call the rectangle function, pass in the device context as a first parameter. Device context is basically where you want to draw it. It can be, for example, the whole screen or maybe a specific window. Afterwards, just pass in the coordinates, and you have a rectangle on the screen. Now, if you follow along what is going on when you call this GDI function, it's going to go to the win32k.sys driver, and from there, it's just going to direct into the DirectX kernel driver. This is actually called dxgkernel.sys. And you can see over here in this diagram pretty clearly that DirectX is the only one that is actually talking with the graphics driver. In a lot of cases, the graphics driver is going to come from a third party, but if you have a fresh installation of Windows with no third-party graphic drivers installed, you're going to have the Microsoft fallback, which is called basic display. We're going to take a look at that in a second. You can see even using a different API, for example, Direct 3D, which is more advanced than GDI, lets you do more rich graphics. It also eventually ends up at the DirectX kernel driver. As you can see over here, I brought up VirtualBox and
I mean, the graphics is one thing. I'm more thinking of how the message queue works. I mean, there is literally a message queue on Windows, right? But still, it's not like socket-based. It's probably also integrated somewhere in the kernel, right? I mean, on Windows, there's probably no like... there is kernel mode. There are like rings. There is kernel mode and user mode on Windows, but it probably doesn't enter there through like a socket. They're probably just like, syscalls for stuff, and that's it. So you would be able to do that on Linux if like part of the user space was like in the kernel. Yeah. Like it's just literally more integration with like desktop, right? Yeah.
Have a virtual machine called Windows 10. It's a basic Windows 10 setup, and we're gonna just set up kernel debugging on this and take a look at how this works under the hood. Before I'm gonna boot this up, I'm gonna just configure one thing for kernel debugging. So I'm gonna go here to settings, click here on serial ports, and enable the port.
Yeah, it's like the kernel, how to set up kernel debugging.
Connect to the system.
Yeah.
Okay, you can see now that it's successfully connected to Windows 10, so kernel debugger connection has been established. And now it hit the initial breakpoint. I'm just going to tell it to continue execution, because I want to get to the more later boot of the system. This is currently very early in the boot stages. So I'm going to run the G command. That's going to tell the debugger to continue. Now you can see Windows is starting to boot up. Okay, so we got the system booted up. Now is a good time to put a breakpoint and start playing around. And I'm going to break the debugger by running control break. Now you can see it hit a breakpoint, and I now have a command line here that I can start running commands. First command I'm going to run is lm. That's going to be list modules. And this will show me the current modules that are loaded into the kernel. As you can see, one of the modules is called basic display. This is exactly the driver that we saw before, and this is the driver that we're going to play around with in this video. By the way, you can just click on this and get some details about it. You can see how this is indeed basic display.sys. .sys, by the way, is the extension of drivers on Windows. What I'm going to do is I'm going to first examine the symbols that are exported by this driver. For this, I can use the X command. X stands for examine. That's how you can remember this. Afterwards, I'm going to pass in basic display. Then I'm going to use an exclamation point and a star. This is a wildcard that will tell it to list all the symbols that are exported by basic display. Now you can see we get a very long list of symbols, so we can't make much of this. We want to go ahead and filter it.
I wonder where do you even get all this information, right? Is there like a book that says all this, or is this just like some MSDN article? Like, where do you go to find all this info?
The way I can do that is by adding more text here. Let's say I want to go ahead and filter everything that has BLT in the name. What exactly is BLT? So BLT is a common word that is used when talking about graphics. Transfer block transfer. This basically means transfer bit information from one place to another. So we're going to list all the symbols that have this in their name. We can see we have here a couple of symbols. Specifically, I'm interested in this function.
Yeah, you just literally go to his channel and wait for him to cover your topic, right? You're also debugging his display pointer. Shut the fuck up. I only just started to forget a little bit about the fiasco.
It's called fill FB probably stands for frame buffer, and this is something that is very interesting around frame buffer. So let's go ahead and put a breakpoint on this. So I'm going to just copy this name and use the BP command. That stands for breakpoint. And now I'm going to run the G command. That's going to continue the execution of the operating system.
Yeah, I mean, G is for continue. That makes sense, right?
It'll trigger the breakpoint. And you can see now that the breakpoint has been hit. I'll start by using the U command. That's going to be unassembled. That's going to show me some of the assembly that is currently in the line that I'm at. You can see some of the assembly contained in this function. If I just press enter, it's going to show me more of the function in assembly. As you can see over here on this function, it starts with a bunch of initialization on these lines, just setting some registers. Over here on this line is where the interesting stuff starts happening. You can see it's copying a certain pointer over here that's calculating with some registers into REX. And then it's copying REX to some other place. So fill,
like bleed info is some internal stuff in the basic display driver. It's interesting that like the kernel mode debugger has symbols for this, for those exposed. So it's not just like some garbage stuff. It just has actually human readable names for it. Like very nice for Microsoft.
So what I'm going to do is I'm going to put a breakpoint on this line, and we're going to take a look at REX. Let's see what is there. So I'm going to copy this address over here, the address of this line that I'm interested in at. I'm going to use the VP command again, but this time I'm going to pass in a flag that is /1. That means I'm using a temporary breakpoint that will only trigger once. Paste the address in memory that I just copied, and I'm going to execute this. Now we have a breakpoint on this line, so I can just continue execution by using the G command. G is go, by the way. Now I can see our breakpoint was hit. I want to take a look at what is inside of the REX register. To just see the value of REX, I can use the R command. That's going to be R for register, and then REX. We can see a certain value here that looks like an address in memory. Let's go ahead and take a look at what is inside of this memory address. So for this, I'm going to use the display bytes command. That's going to be DB, and pass in REX. As we can see here, the contents of the memory indeed look very interesting and kind of like they're following a certain pattern. Let's look at some more of this memory.
Yeah, those are colors.
This will tell it the length of the output that I want. For example, 100. You can see now I'm getting more lines. It looks like this is following a certain pattern. Now what we're actually seeing over here is the frame buffer. This is really cool, so I can just write into this memory certain color values and it'll display them on the screen. It'll overrun what is currently on the screen. So for this, I'm going to use the F command. That's going to be fill. By the way, this is a good chance to show the help system that comes built in WinDBG. Just go ahead and run .hh. That's going to open the help system and the command you want information about. For example, F for fill memory. Now I'm going to click here on fill memory.
Oh, a flashbang.
And what it does. Just pass in a range and a pattern to fill the memory with, and it's going to fill the entire memory range. So I'm going to start by using F. Then I'm going to pass in the range. So the memory is going to start from REX. And let's say I want to fill up, I don't know, like 10,000 bytes. And I'm going to go ahead and fill it up with FF values. This is FF in hex. And what this will do is basically fill in the red, green, and blue values with FF, just to make the screen white. Now it's not going to make the entire screen white because the screen is larger than 10,000 bytes in the frame buffer, but you're going to see part of the screen as white. Let's go ahead and take a look. So I'm going to run this command. Now let's go ahead and paint another part of the screen in the gray color. So I'm going to run the same command, but this time I'm going to skip 10,000 bytes from REX. And I'm going to fill it up, for example, with 40 instead of FF. So this will basically draw another block of gray pixels after the white pixels. Now I'm going to go ahead and clear the breakpoint with the BC. That's going to be breakpoint clear, and then star. Clear all the breakpoints, and finally continue execution with G. Now let's go back to Windows. And you can see over here the white and gray rectangles. Now let's go ahead and fill up the larger section of the frame buffer, so we'll see this effect more.
So yeah, you can just
at the same place we were before.
Yeah, you see, I mean, why did I even show all that? I know why I didn't like this video, but yeah, because it's a different YouTube account. he didn't like write anything to the socket because it's all like deeply integrated into the operating system itself. Yeah, that's very cool. I wish we could do that on Linux. I mean, you can sort of do that, right? There is GMA, like GMA buff, or what is it called? No, not GBA buff. DMA buff or something like that, where you can kind of like draw graphics without like X11 or Wayland, right? Yeah, DMA buff. So it's kind of like that, right? You can call like very, very tiny user space, like facility to draw graphic on the screen. And, you know, there are examples on a free desktop GitLab, like stuff that just clear screen, or I think there was even not really a game, but an example program where you can like move a rectangle over the screen with your keyboard, so you can literally like create a whole fucking game without any desktop stack on Linux. And I think that's what VR uses, is it not? Weren't there like a bunch of extensions, a bunch of like kernel, not extensions, but protocol got like merged just so VR can draw at a high FPS without having to rely like on X11 or Wayland to like completely circumvent it? Wasn't like that the case? So you can get direct access to the GPU frame buffer. I mean, yeah, it uses Linux kernel for sure, but it doesn't use any of the normal desktop stack. And they have to implement a bunch of stuff. Maybe it's not DMA buff, maybe it's something custom. But yeah, there was like a bunch of effort to be able to draw graphics without any of the janky user space. I mean, it makes sense, right? If you're like a serious company and you want to ship actually like reliable software that draw graphics, and you want to use Linux as your, you know, kind of reliable backbone, you have to throw away all of the user space bullshit, right? That was written by fucking LSD overdosed MIT scientists, or like Berkeley, like academics. You have to throw all that shit away, right? You can't use it. So it makes total sense to me. Yeah, let's look at this again. I'm just gonna look at this and tell myself that I'm not wasting my life, that it's all worth it. Yeah, I would do anything for this gradient. Anything. Okay, but I mean, we made it work. We spent a lot of time on fighting the pointer, but yeah, it works. What else can we do? It's almost 11 p.m. So I don't think I can honestly do much. And it's not a lot of code too, right? It's very little code. It's just one header. Not even a header. It's just one. It's just one file. Not even this one. Linux extras. Right, then it's import here with the create surface and some modifications to the example, and that's literally it. Yeah. I think I'm too cooked to literally start anything else today. I didn't even have like much plans. This stream is just kind of I don't know, let's do something. And if I wasn't such an idiot, this stream would be only like an hour and a half of content. So maybe all of this like fiasco was just a plan to extend the content length, you know, like an artificial filler content, just like in your favorite TV show that you're watching right now. Hey Puka, hello. Have you ever wondered, like you open a TV show and at first it's very good, right? But then you're like, hey, wait a minute. I think they're stalling. And it usually happens like around the second season, right? The first season is like a complete banger. And then around the like end of maybe like couple episodes in the season 2, you start noticing something. That something's not right, that it got quite a bit slower. And nothing really progresses anything. You know, like nothing ever happens. This kind of meme. An episode of One Piece, 24 minutes of anime, but actually 10 minutes new stuff, and the rest is intro and preview. It's not even that. I'm literally talking about events that don't lead anywhere. That, you know, and the modern kind of TV show formula requires you to finish every season on a cliffhanger, right? And so you would have an episode where nothing happens, and then at the end you would have like a cliffhanger, and then at the beginning of the next episode this cliffhanger like turns around and again nothing happens, right? And you have this formula, at least in Western TV show, to prolong them forever, right? And you maybe keep watching them because of the characters that you enjoy, because of their interactions, but not for the plot itself. Like the plot itself is kind of whatever. Yeah. So let's maybe raid someone. Who is streaming? We have Spherophoria. We have Kuju. Oh, we have Foxic. Yeah, we raided Kuju the previous time. Let's raid Foxic. He's another epic Jai game developer. Some shows just do story offset in size. Yes, exactly. Yeah. Plot starts in the middle of the episode and ends. Yes, that's it. And the way they do plots is that it leads nowhere, right? They would like kill a couple characters, right? So we don't notice anything, but yeah, whatever. That's a rather weird fucking rant to end the stream on. But yeah, we're done with Vulkan. What can we even talk about it? And we complained about X11 and Wayland as usual. So, you know, the purpose of the stream fulfilled. All I can rant about is TV show. Anyway, say hi to Foxy. He makes a very cool 3D game from scratch, you know, his own custom engine. And yeah, I also look at my epic shield links, YouTube. Fuck. All the links in the description, right? You can check them out for yourself. Vulkan is like programming fillers you don't need. Yes, exactly. Anyway, I'll see you all tomorrow, probably. Yeah, thank you, everyone. Bye. Thanks for watching.